This is Strumley. In this video, I'll take you through how it works, how I designed it, and how you can build your own. All musical instruments produce sound by vibrating air. This vibration is picked up by your ear. Your brain does a bunch of work to turn that into a brain sound juice, and you perceive the moving air as sound. The way different instruments vibrate the air dictates how they sound. Wind instruments create a standing wave in an air column. The user then changes the length of the instrument to affect the resonant frequency and, by extension, the note that is played. Stringed instruments vibrate a string, which is often amplified by the instrument's body. Some stringed instruments have individual strings for each note. These are mechanically complex, but having multiple strings allows the user to play notes simultaneously. The other type of stringed instrument changes the length of the resonating string by pinching it, effectively shortening its length and resonant frequency. This allows the instrument to generate many notes with only a few strings. Now, my concept is pretty simple. I want to take strings, tune them to notes that correlate to a song, and place them in order, so strumming them plays all the notes in the correct order. The result will be a little instrument that plays a song, no skill required. A string vibrates at a measurable frequency when it's held under tension. If the tension is high enough, the frequency produces a musical note. The governing equation for this relationship can be seen here. T is tension, mu is the linear density of the string material, and L is the length of the string. Now, to keep things simple, I'd like to use the same string material for each note. This means we can lock in mu as a constant. If I use literally the same string for all of the notes, it dramatically simplifies the tuning because the tension will be the same for all of the strings. And that leaves us with a single variable, which is perfect for calculations. I'll rearrange the equation to solve for length, and this will allow us to plug in a desired frequency and calculate a length as the result. To actually convert a song into a Strumley soundboard, it's pretty straightforward. We'll use the lick for this example. If you take a sequence of notes and calculate the frequency of each using the equation we derived, you get a length. Repeat this process for each of the notes in the song, and we have an array of lengths that we need to put together to form the song. I've created a playable web app linked below to make this process a little bit easier. Simply play your tune on the piano and write down the associated string lengths. The details of how these lengths get turned into a Strumley soundboard is something that we do in CAD. The note spacing is set by the V-groove bearings I'm using to wrap the string around. I then put the string lengths into the sketch and draw some supporting bosses to resist the tension of the strings. Once tuned up, the strings will produce somewhere around 80 pounds of tension, trying to rip this print apart, so any and all bracing we can provide will be helpful. And to terminate the string, I'll use a sacrificial bearing to loop it all around. To support the soundboard, I'll make an aesthetic housing which makes the soundboard presentable and should act as a sound chamber to amplify the sound a little bit. Once the CAD design is complete, I'll print and assemble it. The print is designed to fit on a bamboo printer due to its popularity. Once the Strumley is assembled, there's nothing left to do but play it. I've put the design up on my website, link in the description. Please feel free to generate your own soundboards and try out various little jingles. I would love to see someone take this to the next level by building a whole song worth of soundboards. That's it for now. See you in the next one. Bye.